All right, here we go on question 14. Simpson's rule again, 4 steps this time again. We're going to follow the same pattern as we did on question 13. And so what we need to do is figure out what h is. H is b minus a divided by the number of for n. Okay, so don't forget, here's a, here's b. Let me change colors. All right, and so b minus a divided by n gives us 1/4. And that tells us then that for our x number line, we're going to start at 0, we're going to go to 1, and we're going to divide it into 4 equal pieces. And so this is what it looks like: 0, 1/4, 1/2, 3/4, 1. And now we need to know what the y values are at each of those pieces. Well, they gave us a right tricky problem to check that out now. This is going to be something where you may want to have your calculator on the handy side. And so when we look at y0 now, we're looking at 7 over 1 plus 0. Well, thank goodness for small things. That's a 7. Now, y1 is going to be 7 over 1 plus 1/4. And that's no such lucky thing right there. And what I'm going to end up with on the bottom, if I add these fractions together on the bottom, remember 1 is 4/4. So I actually have 7 over 5/4. Okay. But when you multiply, or when you divide, you multiply by the reciprocal. So really it's 7 times 4/5. And that's going to be 28/5 for that guy. Whew. Man, is this problem over yet? Yikes. Now, this one, 7 over 1 plus a half. Okay, 1 plus a half. Well, remember, 1 is 2 over 2. So this is really 7 over 3 over 2. But when you divide by a fraction, you multiply by the reciprocal. So this is actually 7 times 2 over 3. And that's going to end up being 14/3. The next one is y3. And that's going to be 7 over 1 plus 3/4. And remember, 1 is the same as 4/4. So when I do that, that's actually going to be 7 over 7/4. And again, you're multiplying by the reciprocal. And oh, thank goodness for small miracles. That's a 1. All right. So lastly then is y4. And this is going to be 7 over 1 plus 1, which is going to go all the way down to 7 over 2. Okay. Well, this looks like stuff that we can handle. And as long as all my math is correct here, and I feel fairly confident in what I wrote down without looking at a calculator, that this is my math. So what does my Simpson's rule look like? My Simpson's rule then is gonna look like this. It's going to look like 1/4 over 3 times 7 plus 4 times 28/5 plus 2 times, wow, I don't know what that was, 2 times 14/3 plus 4 times 1 plus 7/2. Okay? And wow, common denominator not coming around. It doesn't look like anytime soon. So I've got 1/4 divided by 3. That's the same thing as 1/4 times 1/3. So that's going to be 1/12. I can do the easy parts in here. 7 plus 4, that's 11. Plus 28 times 4. Let me just crank that guy out real quick. 28 times 4. Hold on. Talk amongst yourselves. I don't carry that one in my back pocket. 28 times 4. 112. 112. I knew it the whole time. So this is 112/5 plus 28/3 plus 7 halves. All right, pause video. I'm going to look this up and get back to you with the correct answer, both decimally and fractiony, depending on what your need may be. All right, in my calculations, I did find one tiny little error. That guy should be a 4, which makes this guy a 4, which makes this a 16 plus 7. So this guy right here is going to be 23. So when you add all that up, one way that you're going to get it is going to be 1747. Now, if you did all fractions, you get 1747 over 360. If you decimaled that out and just decided to heck with it, you would get 4.852. All right. So there you go. Simpson's rule again. And you can double check this on your calculator. However, on your test, with me, since the end value is only 4, I will need to see the work and the setup exactly like I've shown you here on 13 and 14. All right, kiddos, on these two problems, we're going to use Simpson's rule and the trapezoidal rule. And not only that, we're going to use our calculators because, hey, I don't want to work out with n equal to 100 between 0 and 1. Not really what I wanted to do. I don't mind working 4 or 5, different trapezoids, but 100's out of my comfort range, okay? Same with on question 16 in the trapezoid rule. I don't really want to mess with 50. So I don't have the online program on my calculator, or I don't have the program we created in class on my calculator. Or I'd work it out for you, and I happened to leave the sheet at school and had planned on being back there today, but hey, white stuff fell. We can't get there. So what I'm going to do is just, if you want to pause right now and punch these into your calculator, please do so. I'll give you a second. Okay, time's up, and I'm going to give you the answers in for 15, which you should have, but just in case you don't, 15 should come all the way down to 2.1202. And remember, these are approximations. These are not exact answers, okay? The reason they're approximations is because we are estimating area with shapes that are rectangles and trapezoids. That's not a perfect fit for a radical, okay? Down here, the approximation for trapezoidal rule, again on your calculator with the program, is going to be 3.1322. All right, so there you go. Good luck.